Hello everyone, welcome back. My name is Sayantan Sarkar. I am a first year undergraduate student of the Department of Mechanical Engineering at IIT KGP. I am a student of section 15 and my roll number is 21ME10073. In this video, I am going to talk about my DIY project 2, which is based on the Tinkercad software. In the software, I have made two circuits based on two different ideas, so two different projects which I am going to show in a single video. So this is my first one, whose topic is factory safety and circuitry. For making this circuit, I have used one temperature sensor out here. I've used two LEDs, one red and one yellow. I've used these resistors to limit the current to the LEDs and the push button. This is the push button. This is a servo motor, which is an actuator. So this is a sensor and this is an actuator, and this is the Arduino microcontroller board, and I have connected all these components using a breadboard and few wires. The purpose of this circuit is to turn on the piezo here, which will play a sound with a particular frequency once the temperature rises above a certain value. Here I have used 80 degrees Celsius as the limiting value, and the red LED glows up as soon as there is a fire occurring or an overheating occurring, which may occur a substitute of fire and for which the temperature may increase. And as the temperature increases beyond 80, if there is a fire, all the emergency doors of the factory will automatically open, which is by this servo motor, which will turn by 90 degrees once there is an outbreaking of a fire, so that the workers can escape out quickly. And this is a second piezo, which is an health emergency or any other kind of emergency piezo, which will turn on only when you press a push button for a particular department if a worker falls ill or any other cases, and this yellow LED will glow up. This is not responding to any sensor. You have to manually operate it. So this is a factory safety and circuitry circuit. For operating this, I have used this code using the blocks. I am reading the temperature sensor on analog pin A0 in degrees Celsius, which will, if greater than 80, then it will turn on the red LED. It will turn on the servo and for 90 degrees rotation, and it will play the speaker for 1 second with 60 frequency. I have induced a delay which supports in various cases, and if we press the switch on, so if read digital pin 7, which is a switch digital pin, if it is high, then the LED, the yellow LED will glow up and the second speaker will play its sound with a frequency of 40 for 1 second. This is, I have converted it into text form and I have copied it and pasted it in Arduino IDE, and it has successfully compiled. So I am playing the simulation. So once I am pressing this switch, the right one piezo makes the sound and the yellow LED glows up. Once I am releasing it, both turns off. And if the temperature is more than 80 degrees Celsius, currently it is much less, it is about 25 degrees Celsius now, and if I increase it up to 80, then the servo, you can see it rotates by 90 degrees so that the door opens and this one piezo makes the sound and this red LED glows up. And I have connected, if I connect a multimeter across this LED, I have seen that the, okay, I am just closing it, and the servo motor automatically closes. And the resistance I have used here, it is of 100 ohm. So you may use higher resistance also, which will limit the current. Here the current across the LED is 50 milliampere. I have checked, but it should be less than 20 milliampere, which is suggested. So this is the operation of my first circuit. Now I'm going to show my second project. This is my second project, which I have made on the basis of a self-driving or the driverless car, which senses if there is any passenger in front of the car, so that it can automatically operate brakes, or it is not braking, it's just stopping the wheels from rotating with a safe distance here I have set it to 150 centimeter, which is about 5 feet, so it's okay. And here I have used this 9-volt battery to operate the motors. So be careful, if you connect the 5-volt of the Arduino for powering the motors, then the Arduino may burn off because of drawing several power. And this this is a multimeter. I have connected it across the piezo alarm. This is an ultrasonic sensor which senses the distance between the passenger or any obstacle and the position on which it is actually present. This is an L293D IC integrated circuit which controls these 2 motors. You can connect 4 motors to a single L293D. I have used 2 motors here. These are the 2 motors of the vehicle. This is an Arduino microcontroller board, as I have mentioned. And the functioning of the circuit is that if the passenger distance with the car is less than 150 centimeter, then the motors will stop rotating and the piezo will pick, or it may turn on volume for some seconds, which will act as a horn so that the passenger gets alert. This code I have written completely in text form. This is the initialization conditions. This is the baud rate 9600. This is a function which is signifying the value obtained from the ultrasonic sensor and calculating the distance using the duration which is obtained from the echo pin. You can see I have set the echo pin and the trick pin to respective values. And here I have called the ultra function, and if distance is less than 150, then you can see all the wheels have the 0 RPM so that they stop, and it will play the tone with different frequencies so that the passenger doesn't get irritated. If distance is greater than 150, then there is I'm assuming no obstacle. We have surpassed the set distance, and therefore the LM1, that is the left motor, the first output will rotate by 60 RPM, and this is for both the motors. So the wheel will rotate and the car will move forward. So for my second part of the project, I am just starting the simulation of the circuit. So let us see how it works. So here you can see the multimeter at 0.0 volt as the piezo is not running. Now the distance between the passenger and the car, I mean not passenger, it is trespassers. If it decreases from 199 to less than 150 centimeter, then the piezo rings up and the DC motor stops. If it is greater than 150, then the piezo stops like this, and you can see carefully that the DC motor now rotates, which means that the wheel is moving forward and it is moving with a particular RPM which is same in both the motors because it is connected by single L293D. So this is my simulation, and I forgot to mention that this code I have also pasted it in Arduino IDE, which is named by Driverless Trespassers Alert, which I have compiled successfully in this system. Here I have attached the multimeter before. I have got the readings and I have disconnected it because of little malfunctioning. So I am stopping the simulation. So this is all for my DIY project. Thank you.